Hi, I'm Lynn Langett. In this screencast, we're going to look at NoSQL Speed with Ease, benchmarking Aerospike on the Google Cloud platform. This is based on work that I've done with David Haley and the Aerospike team. I've been working with Aerospike for a while, and I've already validated 1 million transactions per second. That was actually on a different cloud. So in this work, David and the team and I took a look at whether or not and how we could validate this benchmark or even beat it on the Google Cloud. In this screencast, I'm going to introduce you to Aerospike itself. I'm going to then go into detail on cloud performance benchmarking on the Google Cloud platform, and I'm going to show demonstrations. In addition to that, I'm going to give you a look at the Aerospike developer experience using examples with a Java client. So to get us started, we're going to take a look at Aerospike itself. So to sum it up, it's NoSQL that scales up powerfully and effectively. In case you, like me, are wondering about the name, I looked it up, and it comes from, as it says here, a rocket nozzle that maintains its output effectiveness over a large range of altitudes. So what does that translate to in terms of a product that we're going to put our data into? So the key points for my customers' use cases are that Aerospike is multi-threaded, it's a NoSQL store, it implements key value, it's tuned for both in-memory and persistence using SSDs, and very importantly, it has a powerful auto-rebalancing feature that circumvents the typical complexity that's associated with NoSQL clustering and sharding, and we'll see that in action as I show you the demos. So you're probably interested in getting started, and although we will be working in this screencast on the Google Cloud, most developers want to start by just working with a local instance. There is a free developer edition, so the first thing you need to do once you decide to get started is determine which environment you want to run on. I'll be running using Vagrant for my demonstrations, and I have a Mac. So one of the first things that I think is interesting to look at in Aerospike is the AMC, or the Aerospike Management Console. So in the first demo, I'm going to show you what the console looks like when it's running locally through Vagrant on my machine. So here I'm connected to the console, and you can see that I have the smallest possible implementation. I have a single node, and inside of the console I can see information about my Aerospike cluster, resource usage such as RAM, throughput, nodes, and namespaces. In addition, I can see statistics, definitions, and jobs. So this console is very useful when you're just getting familiar with Aerospike, and additionally when you're doing performance testing, because it's a quick and easy way to get a visual of the throughput that your cluster is supporting. Now, in addition to working with the console, there are client tools that help you to get familiar with working with Aerospike. Before I show you the Aerospike CLI or client tool, I'm just going to cover a couple of core concepts. So Aerospike consists of a cluster, which consists of one or more nodes. And of course you can have multiple clusters, but for our demonstrations we'll just have a single cluster. A cluster hosts namespaces, which are analogous to the idea of a database. Namespaces have sets, which are analogous to tables. Sets have keys and records, which compare to rows, and there are also bins, which compare to columns. I'll show these concepts when we use the CLI next. So I've connected to my local implementation of Aerospike, and you can see here I'm in the console. There is some useful information inside of here, for example the clients, and also the URL to the AMC, which I just showed previously. Now what I've done to make it simple for us to try out is I've actually written a simple script in GitHub, and I'll show it to you, and then I'm going to run it so that we can interact with the CLI tool. You SSH into the Vagrant instance. You could use a different type of host, but if you're using Vagrant, and then you just type ASCLI at the prompt, and if you use the help parameter, then you can see how to work with this command line. Now the first thing you're probably going to want to do is put some data into Aerospike. So to do that you use the put value, and here we're just putting some values into the namespace test, so on and so forth. So I'll just enter this information in, and then if I want to see it I just use the get command. Now, of course, I could also see this on the AMC. So if I refresh it, go to the definitions, and go to test, you can see now that I have one object inside of test. The CLI has a bunch of different commands, and I'm just showing you the bare minimum to get you started. You'll want to consult the documentation as you continue to work with it. And I'm just testing to see if this value exists, and it does. Now, in addition to the CLI tool, you also have the AQL tool. And you'd probably guess that stands for Aerospike Query Language, and you'd be right. You'll notice the prompt changes to an AQL. So the first command I'm going to run is show namespaces. And you can see I've got the test namespace. Then show sets, then show bins. So as you're becoming familiar with Aerospike terminology, this is a useful way for you to interact quickly and easily. Now just to complete my demonstration, you can see I've got a select query here, and that's returning my D value. And to end this off, I'll just do select D, A from test.test. And you can see that value as well. Now that I've given you a really quick introduction to the basics of Aerospike, we're going to turn to working with it on the cloud. Now we'll get to the benchmarking in just a couple of minutes, but again, I want to show you the easy path first because, it might be just quicker for you to get started this way if you're just trying out Aerospike and you're not needing to push it at scale just to have an initial evaluation. So on the Google Cloud, once you have an account and a project, there's a capability called Click to Deploy. And what this does is this spins up or starts pre-created images on the Google Compute Engine virtual machines and allows you to set up a cluster in literally minutes. I'm actually going to do it right now so you can see how fast it is. So here I am in the Google Developers Console for the Google Cloud Platform, and I'm using the new console. So I assume by the time that you look at this, this will be into production. It's in beta right now, and I think it's a public beta so everybody can try it out. So if your console looks a little bit different, it might be you're using the older one. So you're going to look for the Cloud Launcher, and then once you're in the Cloud Launcher, you want to look for Aerospike. And once you click on Deploy Aerospike, then you have a name for your deployment, you have a zone, you have a cluster node count, I'll start with 2, you have a machine type, and then you have whether or not you want to use persistent disks. You can use standard persistent disks, or more commonly you'd use SSDs with Aerospike. And then you set up your data disk size, and then you can optionally fill out these additional parameters. And you have to accept the terms of service, and then click Deploy Aerospike. And I'll note that the time is 4:25. Notice it says it should take 5 to 7 minutes. And I will pause the video and then I'll come back once the cluster is deployed. All right, well that took 2 minutes. So let's take a look at this. And you can see that on my deployment here, I have my Aerospike server. I have multiple instances. So I have my VMs and my disks, and I have a deployment coordinator. If I click on the menu and I click on Compute Engine, you can see I have my 2 virtual machines. And if I want to connect, I can SSH in right here. And then I could work with my ASCLI or my AQL and or my AMC the same way that I showed you with my locally installed instance. So I'm not going to do the same thing to be redundant, but it's really just that quick and easy to get a cluster up and going on the Google Cloud. Another aspect of working with this, and then I go to Deployment Manager. If I click on Trash, that will delete the entire deployment. Again, one of the things I like about working with the Google Cloud with Aerospike is that it is incredibly fast to spin up and spin down clusters with many, many nodes of instances so that I can do performance testing like that, which I'm going to show you coming up next. As a cloud architect, I'm often asked to evaluate multiple NoSQL databases, and I can spend an inordinate amount of time trying to set things up locally and or on various clouds. So this capability to spin up and spin down so quickly has a high value for me. So now let's cut to the chase. I showed you the basic operation of Aerospike. I showed you how quick and easy it is to work with it from a testing perspective on-prem and more importantly on the Google Cloud. Now here's the meat of the presentation. Working with the Aerospike team and my other partners, I was not only able to validate the 1 million transactions per cluster per second, we were able to smash that record, which is pretty darn exciting. We were able to do 4 times the performance, which is 4 million transactions per second. You heard that right, 4 million transactions per second on a single cluster. So if you, like me, are interested in how this was done, then keep listening because I'm going to show you what we did and you're going to be surprised at how quick and easy this was. So in addition to me describing what we did, I've also documented so that you can replicate this yourself. And there's two different resources. David and I wrote a blog post that's on the Google Cloud Platform blog that has a written step-by-step, and there are only 6 steps to set your own cluster. We also created a GitHub repository with a couple of scripts. Both of the links for these are included in the PowerPoint if you download the PowerPoint. So let's talk about some of the details behind our benchmark process. It was really exciting for me to see how easy this was to do. We were able to use a default configuration, no manual tuning whatsoever. We literally turned on 20 GCE standard sized instances. We used N1 standard 8s, which have 8 CPUs and 32 gigs of RAM. Running continuously, that would be nearly 15,000 hours a month, and we estimate that would be about $4,000 a month. The value of using standard architecture to get this level of performance is also important to understand. Working on other clouds, I've been able to get high performance, not this high, but high performance, but it took a whole lot of manual tuning. Some more details, again, we used 20 server nodes, we used 20 clients as well, just to have the network bandwidth, so we weren't blocked on bandwidth. We used Debian Linux. The data was 10 million keys. The record size was 150 bytes, 20 byte key, 3 fields. And we used the Aerospike benchmarking tool, which comes with the Java client. Now, in addition to using the command line tool, we got access to a graphical user interface tool called White Sands. And so when we show you the replication of our benchmark coming up here in the next demo, we're going to use the White Sands tool. And you can think of this as a replacement for the Aerospike management console. Now, this is not publicly available at this time. It's a private tool that the Aerospike team uses. So if I were not partnering with Aerospike, I'd probably just use the AMC console. And in fact, that was the initial tool that we used, and that's the screenshots that you see in the article. You also, of course, can just get the output from the command line if you want to log it. So as mentioned, we have a GitHub repo. So I'll show you where that is and what is inside of that. So before I go to the GitHub repo, here is a link to the article, Speed with Ease, NoSQL in the Google Cloud Platform, that Google published on their blog. And here is the GitHub repository. The most important item in here is the GCE_CLI_steps.sh, which is a shell script, of course. And it is I'll just scroll down, it is about 165 line shell script, but really it's only about 130 because the last steps are to stop everything and turn it off. It's a 130 line shell script that we think is pretty well documented. So you can replicate the work that we're going to show you here coming up in the next demo. So now it's time to run the load test demonstration. We're going to start in the Google Developers Console, and you'll notice that we don't have any virtual machine or GCE instances at this time. We're going to run sections of the script to set up the 20 nodes for the server and the 20 nodes for the client, and then we're going to start the workload and use various clients to look at the results. So let's get started. Now the script takes a couple of minutes to run, and if you're going to replicate the test at the volume that we used, you will also have to request a quota increase through the Google Cloud Console. And I'll show you where that is in just a minute, because the default maximum number of CPUs per project is less than what we used. It takes about 24 hours for Google to approve your request. Let's take a look in the console. And I'm going to refresh. Oh, before I do, this is where you'd request the quota increase. And here we can see our server nodes being started. And as mentioned in the previous discussion, these are N1 instances. Once the virtual machines have been started, in the next step of our script file, the configuration files are updated. After the configuration files are updated, the IP address of server 1 is used as the mesh address for the cluster. Now the script is creating our 20 client instances. As we did with the server nodes, we can refresh the console to see confirmation of our newly created client instances. Let's go back to the script. In the next step of the script, Aerospike is being started on each server. Now our setup is complete. We can view our cluster using the AMC. Here's the address. And you can see that we have 20 nodes ready for action. Are you ready to see the benchmark? Here we go. Well, we're already over 1 million writes per second. You may remember from earlier discussion, that was the original benchmark. Let's see how much better we can do. Notice that we're only using 35 gigabytes of the total RAM available. Here comes the read workload. The read workload hits 1 million, and the write workload remains at 1 million. Remember, this is transactions a second. So here we're showing a mixed workload, which is something that I just wanted to try, and I'm really happy with 1 million reads and writes per second. However, you might remember that in the other benchmark type of testing, we did a read-only workload. So I'm going to stop this test and rerun it with a read-only workload and show you what we get with that. All right, we're restarting our test to replicate the read-only workload. So let's go ahead and turn that on. And we're first going to see the write traffic because we need to insert some data into our cluster so that we can then read it. And now we see the read traffic starting. And we're up over 1 million reads and over 1 million writes per second as the writes are continuing and the reads are now escalating as the writes are completing. We're up over 2 million, 2,000,005, up to 3 million, 3,000,005, and there's our 4 million. So 4 million transactions per second on 20 nodes on the Google Cloud. Simple to replicate, and I think very beautiful. As we continue to let this run, you can see that we're up to 5 million reads per second. So as mentioned earlier, in addition to the AMC, working with the Aerospike team, we also got to work with the White Sands client. And I don't know about you, but I just love this 5 million transactions per second, 20 nodes, 200,000 objects. Pretty exciting stuff. Oh, here we're up to 6 million. So let's look back at the console here. And you can see we're going up over 5. So this is just an alternate client and pretty exciting stuff. So validating the demo, and we invite you to try it as well. So again, just to recap this, 4 million transactions per second on a 20 node cluster. So I'm assuming a lot of people watching this are developers because that's my typical audience. So hopefully you're excited and want to get started using one of the client libraries. Now I've developed for Aerospike with Java and C#, but you'll see all these various languages are represented and Aerospike has libraries for them. Before I show you the demo using the Java client library for Aerospike, here's just a little bit more of detail about the data types that are supported as of this recording. So integer, string, list, blob, map, and large data type. And we saw this with the CLI client to work with key values. We have put and get, we have scan, and a number of additional methods in the programming model, which you'll see in my demonstration coming up. We have the ability to query. We have aggregations with map and filter, and Aerospike supports user-defined functions as well. So as with the previous demo, the Aerospike Java client library is a repo on GitHub, so I'm going to show you where that is first. So here's the URL for the Java Aerospike client demo that I'm going to show you. So if you wish to work with this, you can just pull it down from here. And Jim also wrote a client demo. Let me show you where that is. Here's the URL for the C# client demo. So Aerospike, of course, has extensive documentation, but we wanted to make the quickest possible quick start so that you could see in a single file how to work with Aerospike in the most common ways. The core file here is just program.java, and I'm going to go ahead and bring up Eclipse and show you what this looks like. So here we are inside of Eclipse, and I've just loaded up that project, and you can see that it consists of import statements and a number of simple methods which demonstrate the most common working with Aerospike. So you can see that I first, and this is connecting to my local instance again. So I first modeled the connection here. So this is the path to connect. Notice that Aerospike uses this concept of a policy to specify parameters around connections and activities, and we'll see what that looks like as we run some of these. And then inside the main, we're just calling the various utility methods. So you can see again, I've got a couple types of policies, and you are going to want to look at the documentation. So you've got plain policies, you've got write policies, batch policies. Some can have timeouts. Here's my test, and I can do my various activities like writing a single value, checking if a value exists. And notice here I'm passing the client, the policy that's associated, and then my key. That's the general pattern. So we'll just look at a couple of these methods, and then we'll run this so you can see what it looks like. So you can see that these are operations around writing values, and we're writing single or multiple, and then here we're writing with TTL, and then we can read all or some, and then we can delete, and we can add records, and we can add in batch, and then we have multi-operations. So I'll just show you what some of these methods look like, and then we'll run this and look at the output. So single value just uses a put, and we pass the write policy and the key and the bin. An existence check uses an exists, which this is reminiscent of what I showed you in the CLI. Adding a single value is an add. Writing multiple values is a put. Writing a value with a TTL is a put. That includes TTL. And then I'll just kind of scroll down and show you multi-ops, because those of you that are interested can kind of take it from here. I'm going to go ahead and run this. And you can see I wrote verbose output. Again, this is really just a training file so that you can get used to the operations in Aerospike. So again, you can kind of see through whether and how everything works. So hopefully you find this to be useful. Like I said, this is really just a summary of the Aerospike documentation. It's something that I did for a client, and I thought I would just share it with you because you might find it useful when you get up and going. So hopefully you're intrigued. This is a very powerful NoSQL database. Now, if you're like me, you're intrigued, but you want to know more. So I'm going to leave you with some homework, links to a white paper that talks about the underlying mechanisms that Aerospike uses for scalability. So I recommend you read this white paper. It's very well written. Also, an additional presentation by one of the members of the Aerospike team that was given recently at the Los Angeles High Scalability Group meetup goes in more detail into the underlying architecture. It's kind of fun to end with the inspiration for the name. This is a picture of a twin linear Aerospike engine. So I want to summarize by saying that this is a database that can scale incredibly easily and is very powerful in terms of the NoSQL world. So when you have architectures for which you're looking for NoSQL solutions, you'd be well advised to take a look at what Aerospike can provide. It's important to test and benchmark any data solution, but what I find as an architect, as customers are building more and more complex NoSQL plus relational, NoSQL plus Hadoop, so on and so forth, appropriate testing and benchmarking is going to lead you, particularly if you're using the Google Cloud, to selecting the appropriate GCE instance types. We just use standard. Also, the appropriate quantity. Frankly, I was very pleasantly surprised at how much performance we could get out of a very standard implementation. I'll be really excited to hear what you do with Aerospike. This is Lynn Langit. Have a great day.